Hi everybody, welcome to Byte Ventures, where we deep dive into the marvels of technology. In today's case study, which is the part 3 of this series, scaling productivity on microservices at Lyft, we'll deep dive into what are the challenges they faced after they have done the local development fixes and all stuff. Okay, let's go through some recap. So in the first part of this video series, we talked about one box. So one box is like a dev box deployed on a cloud machine, and it ran all of the services. It's like running all of your services or in together Lyft as a whole for each individual person. But they faced serious challenges of scaling it up when their number of services or the number of developers grew beyond a certain numbers, and it was too heavy and time consuming for each developer to run an instance. In the second part of this video, we saw that Lyft talked about local development environment. So in this case, they have solved the problems of part 1 very effectively, but with current changes running in local. So instead of this, each service was running in a local machine, and for any other services, they need to depend on the staging environment to have a collaborative environment in that case. But the major challenge in this case was doing an E2E or end-to-end testing. So once a feature is developed, how do a user or developer just test it out that, okay, it just works fine when everything is integrated? It's like an integration test, right? And that was a huge challenge, which was still a problem in part 2. So in part 3, we'll focus on how did they solve this problem using staging for the end-to-end testing. Okay, let's talk about staging environment in the first place. So staging environment, as you might know, is a pre-prod environment. So any changes that goes to prod has to go through a staging environment just to do a sanity check, just to make sure that everything is working as usual on this environment. So it runs the same tech stack for that same reason, that we should not see any surprises in production with scaled in resources, fake data. And in this case, Lyft had a synthetic web traffic generator, which would use to generate web traffic, which would mimic the production data, timelines and all stuff, help to mimic any production issues that would occur in this change. It was a first-class environment. So what do you mean by first-class environment? So that means this has to be kept very much sane. That means any production issues had to be solved with whatever severity it would have been received in production. The most important thing going through this case study in the first place is the extensive development using, there is a typo here. Okay, the extensive development that we are doing in staging can lead to a lot of bottlenecks, because if, let's say, 4 or 5 developers are working in 5 different features and each of them are using staging environment, if you see an issue, you don't know for whose changes this issue is coming to you in the first place, right? That is the first problem of having things in isolation. So that is why we cannot use the staging environment as is, because that can lead to service outages in case one of them deploys a buggy PR. The general process of deploying things on staging is going through a merge process as well. So you merge your changes into your main branch, and that would enable a build which would go through a staging and then it to go to pre-prod or prod, right? So, but in this case, it had to follow code reviews, integration tests, and all stuff, which were like a lengthier cycle. People didn't want to go through that. And for that reason, people found a workaround that, okay, let's merge this PR directly in the staging environment and we'll just see what happens. But this led to much more distractions, because now that we don't know what exactly is the change that is deployed, because people were merging commits without any standards and all stuff, led to much more chaos than ever before. And that is when Lyft engineers thought about, okay, we should delve this problem very effectively, and they thought about something called as staging overrides, a very interesting concept. And let's see how the staging overrides work. Okay, what exactly is a staging override? So staging override, as we talked about, is a major challenge tackling the convention of isolation, because if you think about multiple people deploying multiple changes, it's hard to identify which change or which pull request is causing this issue. So what they wanted to do in this case was to isolate the request, even if it was a shared environment. That means even if the staging environment is a single piece for everyone, but they could isolate requests. So if some person is filing a request, they can know that, okay, this request is going through only my service changes, none else. So if it fails, then it is failing because of my changes. If it works perfectly fine, then my changes are perfectly fine in the staging as well as it will be in the production. So for that reason, they decided to have something called as offloaded deployments. We'll get to know what exactly is offloaded deployments. So think about it like a branch taken out just to deploy in the staging environment. We'll have information on this shortly. So when we have offloaded deployments, we need to make sure that the requests are routed properly into these offloaded deployments. Okay, so this might be a little bit complicated. Let's take an example. Okay, so there are three users. Let's say it is user 1, this is user 2, and this is user 3, right? So, here my handwriting, sorry. So this is the usual path. This is the stage proxy, and this is the bunch of services that are running the onboarding service. These are a bunch of clusters or bunch of VMs running fraud service, and this is bunch of systems or computers or whatever you say it running the user service, right? Each of them is running the latest commit or the latest commit in the main branch or the master branch, whatever. This user is trying to test out a feature on this onboarding service. She is trying to make a change to this onboarding service with her new change. That is a new change. So if she just goes and deploys this here, then all of these people who have been using this route will be impacted in case there is any bug, right? What exactly we did is like, this is the case of offloaded deployment. So we did an offloaded deployment wherein the usual traffic is not impacted, and we create an isolated environment for the request sent by this user. So what exactly is that? So in this case, when this user wants to request, she will say that, okay, after the staging edge proxy, instead of hitting the latest onboarding service, hit my service, and whenever the response comes out, feed it to the fraud service. In this way, I will test it out whether this onboarding changes is performing as the current onboarding changes as well, right? And this would go very smartly because these people won't know. That is the whole idea of having offloaded deployments and staging overrides. Okay, let's talk a little bit in depth about offloaded deployments. So what exactly is offloaded deployments? So if we dig deeper into the architecture or the infrastructure, we know that Lyft deploys each service and an Envoy proxy as a sidecar dependency. That means each of this node that have this service running should have an Envoy service running as well. So this Envoy, if you know, this has been developed by Lyft in 2016. This is a load balancer service. It's pretty effective, very, very smooth, and it's pretty performant as well. And many of these companies have been using Envoy as the load balancers. So basically this used to handle all of the networking, monitoring, alerting for this service. So if this service need to send out the request, let's say service B or service C, it doesn't need to care about it. It just send the request to Envoy. Envoy will take care of fanning out the request to the right proxy or the right healthy instance, I would say, right? So ingress is something which is incoming to this Envoy, and egress is something which is outgoing from this Envoy. The config is kept up to date via the control plane using Kubernetes events and XDS API. So XDS API is something which is provided by Envoy. So XDS is like a discovery service, and they have used all sort of discovery service. For example, think about this. A load balancer would need to talk to a bunch of other places to know that, okay, what exactly is the healthy instance for this, right? And that is how this whole service mesh works. And in this case, they are using XDS API. Okay, I'll not go into much details. This is a little bit critical topic on a networking side. I'll attach some documents, probably will go deep into how Envoy works internally with all of these things in a later video. Okay, so this offloaded deployment worked in that case because it was being handled smoothly via Envoy. So let's see how exactly things were working. What exactly were the service discovery? What are the changes that were made to make sure that the offloaded instance receives the requests that are sent by the developer who wants it to. Okay, so first things first, we marked the pod as offloaded instance so that it'll help us to separate out that, okay, this should not get detected. Think about this, right? So if you go back to the last diagram, so here, so if this user is sending out a request and it lands to this place, this staging H proxy should not send this request via this route. That means only certain requests that are reaching this should go to here. So what would be the case? So there should be a filter here, right? It has to filter out that, okay, if I want to send the request to this path, I should know somehow how should I filter it out and what exactly is better than sending it in headers, right? So that's how they did it. So they denoted a pod as an offloaded instance, and they modified the control plane because control plane was everything that was needed to flow the whole request, decide where to route the request and all stuff. They modified the control plane to filter out these instances. But someone has to know when to send this request to here, right? That is where embedding metadata came into the picture. So in certain cases where they wanted to send this request to a particular instance, or in this case, a commit ahead of the latest commit in the onboarding service, they need to embed that, okay, for this request, I need to send it to my onboarding service, right? This will enable the offloading calls that we're talking about. So Lyft used open tracing. So if you know about open tracing, so open tracing is an initiative where any kind of measurements or distributed tracing did not depend on any kind of vendors. It was like a standard, or the creators wanted it to keep free from any kind of vendors, services, and all stuff. So they used open tracing already to propagate the trace info from one service to another. They wanted to enable the offloaded calls in the request header for a couple of purposes. One, it would be transparent to all of the services that are downstream or that are consuming from this service. Second, everyone would know what exactly are the requests that are getting replaced or redirected, I would say, right? So if you know about open tracing, there is something called as a baggage, if you think about this, right? So baggage is a key value store or a concept which is kind of like every header has a key value store, and you can override certain things. You can put certain things as a map over there as well. So that means developers had to update the headers, isn't it? So developers want the headers to update, for which they want those requests to land in their services. And that was a huge challenge. So what exactly the team did was leverage the proxy app. So if you remember our part 2 of this series, we talked about a proxy app. So the proxy app was leveraged here to intercept the request and response, of course. And with this function called the set envoy override, they would say that, okay, for this service, send it to this SHA. And this SHA would figure out what exactly is the IP of that instance and then route the request correctly. And this would eventually amend the header by decoding the base64 format, appending the value, then encoding, and then proceeding it further. Okay, this part is done. So now we have amended the headers, and we have said that, okay, when you see this header, just send it out to my service. But who would send this out? That was the responsibility of Envoy proxy, because the service or the business layer did not have any context what exactly is happening. So whenever one service wanted to send request to another service, the service sent the request to the Envoy that is sitting as a sidecar deployment in the same node, right? So that means we need to change things in Envoy proxy or set some kind of a middleware which would tell that, okay, if I have these values in the header, or if I have an override value in this header, just send it out to that instance when it reaches that service. So Lyft very smartly used the Envoy's HTTP filter in this case. So what was the responsibility of filter? It was pretty simple. And the HTTP filter in case of Envoy read the override information. That, okay, what exactly is the override information? Is this something necessary for me to take action in this cluster or the next upcoming cluster? And if yes, it would modify the routing rules. Instead of pointing to the main branch, it would point to the local developer's branch that is deployed as an offloaded deployment. And that's how it works, right? It has been a great experience for them because that has solved some of the bigger pain points. And here are the results. So user can have the pull request or the changes in end-to-end testing in less than 10 minutes, which is taking more than an hour using one box, because one box was spinning up all the services in that instance. And then if there would have been any failures, it would have required a rebuild and all stuff. Everything was seamless because you just need to do another deployment using GitHub Actions and all stuff. Pretty amazing improvement. Furthermore, one box was not running in the exact same infrastructure as that of production, but as staging used the same kind of environment just to detect any issues or to avoid any surprises, the infrastructure was same in staging. So infrastructure parity was compared line by line, and then any issues which would have been caught in production directly would have been caught in the staging environment now. Furthermore, the confidence. So people who have had one box still did not have very high confidence on the feature, because as it was running on a different VM, different kind of timelines, traffics and all stuff, they were not very highly confident in pushing out the feature. But here the functional parity was taken care of very easily, and that let go of a very big headache for the developers who are developing the feature. And yes, that's all they had. And these are some of the future works that they're still talking about, which is pretty interesting. So one of them is called the shareable baggage. That means if you were using some kind of baggage, there should be a mechanism to share that baggage between multiple developers. So it's kind of like a store. So if you kind of think about that, you say that, okay, this service is running this SHA. This service is running this SHA. This service is running this SHA, right? SHA or SHA, whatever is the encrypted hashed commit version of that. And this would be very useful to share your work with a peer developer and all stuff. So the override feature that they made can be used to test out a lot of various cases. Think about it. So for example, in a request, they just add some kind of, this just adds some kind of parameters to say that, okay, add a latency of 10 seconds to this, which would require it to perform at 8 seconds and would be given a timeout or some kind of exceptions at 10 seconds. Let's see what exactly is the behavior of the service when we try to modify it. It's kind of like a synthetic web generator where you kind of amend the request as per the need and test out what exactly is the behavior of this kind of request going into the servers, right? And the third and the most important thing that I'm pretty excited about is the integration with local IDE. So now we are required to do an offloaded deployment to test our service, right? So they're claiming that they're working on something where you don't need to deploy an offloaded instance as well. What you can do is you can just build your local machine and then use that as an offloaded instance so that when request comes in, it goes through your service. So it'll be so easy to debug and see exactly what happens, right? That would be so cool. I would love to see this feature in action. And yeah, that is all. That is how they solve this problem of making sure the end-to-end testing is working. That's been pretty interesting, and it has given them huge benefits on the developer productivity. That's all I had for today. Let me know if you have any questions or feedbacks in the comment section. If you have any questions, I will attach the official documentation in the description of the video. Until then, take care and have a nice day.